So welcome. My name is Craig, and we're going to talk about using MySQL Heatwave to do some weather forecasting, but with the big twist. So I have, what, 20, 25 minutes? I've done this in 10 because I was really concerned about the 20-minute thing, because that's pretty quick. So here we go. So real quick about myself. I started working with Oracle Tech in '89, and I do a lot of database performance tuning and forecasting. But then when machine learning started getting going again, I jumped into that, and with generative AI, it's just getting better and better, like literally every day, which is part of the weirdness of it. So 1990, I think, is the first recollection when I was actually kind of hooked in this whole thing, because I wrote a learning tic-tac-toe program that learned faster when I created another player, and then I could actually join in on the game. And that was just like, cool. It's the same kind of thing that attracted me to that, which is why I just love all the AI and machine learning. So I've written a couple books, teach a couple classes. I actually have deployed some of this stuff. I just don't talk about it. And the coolest thing is an Oracle tuning AI assistant. And if you want to play with that, there's a QR code. You can do it. And then we got the demo running at the booth outside there. It's called Shane. He's got a surfer persona, so it's just not your typical ChatGPT, boring, don't hurt anybody kind of thing. So there's the QR code. I'll show you that at the end too. So I work for a company called Viscosity. I'm a Viscosity's applied AI scientist. I'm a founder of a company that they acquired. And if you've been to like almost every Oracle conference, you'll see somebody from Viscosity speaking, whether it's about the data, whether it's apps, EBS, Apex, that kind of stuff. Any kind of performance tuning, that kind of thing. And cloud data and Exadata, somebody from Viscosity is probably going to be there. There's two of us here. I'm in the upper right. Charles is sitting over here. So there's two of us here this time. Tons of content. All right, that's the quickest introduction I've ever done. So that's good for a good start. So we're going to talk about rain forecasting. So, the plan. Okay, so the situation, what's the use case, where's the pain? Then I'm going to talk about the flow, like how this app is actually kind of constructed and flowed. And then it'll be ready for me to talk about the architecture. Okay? And then I'm going to get real specific about how I integrated MySQL Heatwave into this whole process. And the initial presentation I put together, I hardly put any of that in there. I put the Python stuff. So I was talking with the gal who's helped me out on this. She said, Craig, it's a MySQL conference. I said, yeah, but that stuff just worked. It was actually so straightforward. All the challenging stuff was all the Python stuff. And so I took the Python stuff out, and I'll tell you about the MySQL, but I thought I should mention that. So we'll talk about the architecture, the MySQL parts to it, and then some surprises, some very pleasant surprises in this project. So that's me. So I like to hike. I love to backpack. Okay? And where I live, though, it rains a lot, and I got a cool graphic here. It rains a whole heck of a lot. And so I don't like to carry extra stuff. So I want to know if it's going to rain. What really irritates me is when the forecast says it's not going to rain, but then it does. That's the worst, right? And so I thought, well, maybe I could use some AI, some machine learning to actually help me out. So I want to know if it's going to rain, but it's an interesting, classification problem, because I want to know if it's going to rain from now to 6 hours into the future. That's the kind of forecast I want, because usually most of my hikes are within less than 6 hours. So have you ever heard of a 6-hour rain forecast? No, neither have I, right? And even the ones that are local are not always so local. So I'm thinking, hey, maybe I can use some machine learning to actually pull this off. Okay. So my objective then, I wanted to build some kind of an AI, some kind of app that's going to forecast the likelihood of rain from like right now, when I refresh the screen, right, to 6 hours out into the future. And so that's what I was going to try and do with all the AutoML and all that. So if you're in the way back, you can't see this, I know. So turn around and you can see it then. I actually cut off some of the beginning right here that says, hey, so let me back up a second. Okay, the data is being pulled from Weather Underground. Okay, anybody can get an API from Weather Underground. So all you need is the API key and the weather station ID, and then you can pull the data just like I'm doing right here. And then you can download the code and all that kind of stuff. Okay. So before we get to this right here, does the ML model exist? Well, I've already contacted Weather Underground and tried to pull some data to see if we can successfully get the data. Okay, so now there's two flows here. There's a training flow, which means the model does not exist. So I need to got to create that model. And then once I have a model, then I can actually do the actual prediction. So it's actually pretty straightforward. So what's going to happen if the model does not exist, right? I'm going to grab some historical data from Weather Underground. It's actually really quick. You can gather like about 6 months, maybe a year. But the more data you gather, the more they throttle it back until they completely shut you off. I know that because they did that to me. Okay, it's not real fun. So you get that weather. I'm going to do some. I do the API call to get the weather. I'm going to do some pre-processing. Okay, in Python, I got to label my data, which is actually pretty tricky because of the 6-hour thing. And then I'm going to save the data in just your standard MySQL database. And then I'm going to call the MySQL Heatwave AutoML, which, and then I'm going to save some information in a MySQL database. Okay, this whole training flow took less than 3 minutes for the data that I had. I just had a two-node cluster. I don't have a whole lot of data. Okay, less than 10,000 rows for this. But I was still like really amazed at how fast, because a lot of times people think, well, I'm just training a model. Well, it's more than that, because in the AutoML, you don't actually know what model, it doesn't know which model it's going to choose until it starts doing like multiple trains, right? And it's got to basically converge on the best model that it can come up with, along with all the hyperparameters. So the stuff that actually takes a person days to actually do, it can literally be done in like less than 3 minutes. I was actually really, really pleased by that. Okay, so now I have my model. So now I can make the prediction. But if I already had the model, I'm going to go straight to the prediction part. So what I'm going to do, I'm going to get some recent Weather Underground data. Now I still need to get some data because this is a forecast, and I want to know what's recently happened. It's just like when you look outside the window before you go take a walk, you say, is it going to rain? Because we know what's happened in the past. We're going to use that information to predict the future. So it's the same kind of thing here. So I'm going to grab just like a day's worth of data, max right here, super fast, okay? I got to do some more pre-processing of my data because I did that up above here, and the model expects this pre-processed data. Okay? So once I get that, then I'm going to load the AutoML model into Heatwave. I'm going to make the prediction, which is like, bam, it's so fast. It's amazing when you talk to people about machine learning that haven't done much of it. They think all the number crunching happens when you make the prediction. The prediction is the building of the model. The number crunching and the time and the resources, the training of the model. Once you have that model, depending on the type of model, it's like, bam, super fast. So this is just, if you have the model, all of this takes less than 2 seconds, and you see it on your phone. It's incredibly fast. So you load the model, you make the prediction, I'm going to format, and I'm going to return the results. And it works really good. Okay, so from more an architecture perspective, on the upper left, that's the Weather Underground, and you see all those weather stations. So on Weather Underground, well, I'll just say there are thousands of personal weather stations out there. Okay, I have one at home, and I voluntarily have it upload data to Weather Underground. Okay, happens all over the world, these weather stations, and so it's kind of a repository for that. And anybody, you don't have to have a weather station, even though they make you think you do. You don't. You can get an API key, and then you can actually pull that data. Okay, and that's where I'm getting my source of data. I like it better than airport data because it's formatted simply, and it's really easy to do in terms of formatting. So that's the Weather Underground. Up on the right here, that's my users just hitting the refresh button and getting the forecast. So there's an app that's Python-based right here that I wrote, and so that I can pull the Weather Underground data from there. I can get a request for the forecast, goes to the app, I can send the results back. Okay, so that's boom on the lower left there. On the right here, that's all the MySQL and the MySQL Heatwave stuff. So there's a lot of communication going on here. Okay, so let me kind of run you through like the flow, but let's look at it from an architectural standpoint. So the user says, hey, I want the forecast. So you put in the station ID and your API key, which is really long, so you're going to want to copy and paste that the first time. So that request is going to go into the Rainforest app. The Rainforest app is going to see if it can actually connect to Weather Underground and pull a little bit of data. Remember I said that. Now, based upon that, it's going to call, it's going to say, hey, does the model already exist? So I'm going to check that in the MySQL database. Okay. If the model does, it's great. It's going to load it into Heatwave. We're going to make the forecast. It's going to send it all back, and the user's all happy, right? If the model doesn't exist, right, it's going to figure that out. Then AutoML is going to kick off here in the Heatwave cluster. And that takes like 2.5 minutes for that to take place typically. Save some stuff in the database, send it back, boom. It works like that. So it works just like fantastic. I'm super happy with it. So let's talk about some of the MySQL Heatwave, how I integrated this. So I wrote it in Python, and I was, this actually worked really well. The most difficult part for me was just getting the connection stuff, all the libraries right. Once I had that, I just wrapped it in some real simple Python, and it just worked. It was really, really good. So one of the first things I'm going to need to do, once I have my data and I pre-process it, I'm going to load it into a table right here, because I'm going to give this to the train call right here. So I'm going to create that table, and then I'm going to make a call to the ML train right here. It wants to know my data. It needs to know the table that the data's in. And this is a classification problem, because I'm going to get a discrete answer back. Yes, it's going to rain within 6 hours, or no, it's not going to. So the label is actually named label. That's what that's all about. And it's classification, and I wanted AutoML to optimize on a specific metric. So I'm not going to get into why I chose that, but I have the flexibility to actually do that. Okay? And you just say go boom, and 1 minute and 53 seconds, something like that, it's trained. And yeah, it's trained then. So it's really straightforward. Now, once I have the model, I can ask for my prediction. Okay? So this is how I'm going to check, hey, does the model exist? Right? Hopefully it does exist. And so I just give the station ID, and I'm calling MySQL database is where I actually store this information. Okay? This is kind of a lookup table in a way right here. So it's really simple, basic select statement. I just got a little wrapper around that, and it just does it super quick. Okay, so this is where gets a little, there's a lot going on right here. So I've already gathered some of that recent data to make the prediction. Okay, I do that pre-processing, and I want the last row, the most recent row, that has all the data that I need to give to the model to make the prediction. Okay, but I want to know the exact columns that the model is expecting. All right, so what I'm going to do right here, that's all my data I have available, and then I'm going to select the column names from the model catalog for my specific model. And that will return to me the columns that I need, and the data that I know that I have the ability to give it, I already have up there at that most recent data. Okay? So with that, I'm going to build this one row that I'm going to give to the predict call. So that's what this stuff's all about. And you can see I'm going to, from my most recent data, this is the column that I'm actually going to grab. Okay? So that's probably the most code copy and paste and stuff that I had to actually do. So what I want to do then, once I have this SQL right here, I'm going to run this right here. Okay? And what this is going to do is going to set that session variable of the row input. And I need to do that because next I'm going to make the actual prediction call. Okay? Now I need to load the model into the cluster. Okay? If you're not used to using Heatwave, that's probably like, what? Yeah, you got to get the model from the MySQL database. I got to get that into the MySQL Heatwave cluster. Okay, so that's what that load model is going to do for me. It just takes a second. It's actually super, super fast. And then I actually make the prediction call, which is like super fast. So there's my row input. I need that data to give it. And then I need to know that model handle right there. It's a select statement. So it's just the standard, run the select statement, and it comes back with the result. And you get the forecast, and it just works. And then I unload the model from the cluster And then the user gets the results. And this is an actual, I didn't like mock this up. All right, this is an actual screenshot of what you could actually get back right here. I mean, I guess if you got close, you could see it. But it says within the next 6 hours, it's not likely to rain. There's a 21% chance it will rain and a 79% chance it's not going to rain. So now not only do I get the yes or the no, I get the percentage, which is actually, like how confident are we about this whole kind of thing? Okay, so that's how it all works. So the surprise is, hey, I'm going to make my time limit, so I can just relax right now. Okay, so the stuff that I was actually, I guess maybe surprise isn't a good way to put it, but it just worked. Like I started with, the AutoML was amazing. There's so much that goes on behind that, which relates to the documentation because it links to a paper that some folks put together, and it was awesome. I haven't read the whole thing, okay, but it's like I'm actually going to load it into my AI and have it just summarize it for me, and then I'll go back and look at the details, I think. But anyways, the quality of the models appear to be really good. There's a nice choice of models that AutoML can reference. As you saw the calls, it's like stupid simple, okay? You do not need to be a data scientist. You don't have to know like anything really, which is kind of dangerous sometimes, but it works really well. Yeah?
So for this to work as application, you must have a lot of data coming in also at the time from the sensors and and then your backend is being kind of, so I can't say it's I don't know what I would say the real-time system. It's coming and then at the time you are predicting as well as if the model is already for half hour valid and then you provide the answer to the query. If not, then you are continuously processing.
No, I'm not. It's a really good question. Okay, once the model is created, it's like static, it's saved. Okay, I'm not going to automatically refresh that unless I want to. Okay, so the model's there. Okay, it's been trained. Now eventually it'll get like maybe out of date later, so I might want to recreate it. During today's presentation, did you notice they talk about the drifting in that? Oh, I love that. Whoever came up with that to build that in was genius, because that's going to solve some of this problem. Like, well, do I need to retrain it? Okay, so all I really have to do is just drop the model, and it's not going to exist, and then it will then automatically recreate the model. So that's static. But when I make the real-time forecast, I just get the most recent data. That's not actually loaded and retrained. I just use that to come up with that one row that I need.
On which your model is supposed to answer the query, right?
Right, it goes off the existing model. Yeah, that's really, thank you for asking me that. One person, when I was talking about this, she asked me the same question. I said, oh, no, it's static. I build it once and we're good.
Okay, so the magic of Heatwave was that because it provides like storing the data, and also it provided you to, I don't know, did it provide you to ability to deploy your model as well?
Yeah.
Okay.
Oh, did it? The model was there. I just had to connect to the database and just communicate with it. Just like would have to do with any other, like if it wasn't MySQL, if it was just like scikit-learn and another, you're still gonna have to load that thing. And it was way easier to type load model. I mean, this was so much easier, and I didn't have to know the file name. All I need is the model, and it's just there. I mean, that's why it's actually so much easier. It's more stable, I like to say. Anyway, so the Heatwave speed, like I told you, took like less than 3 minutes to train this thing, and not just train it. It's actually to do all the AutoML. So I can't stress that enough. There's so much going on, it can be deceptive when I just say it trains a model. It like trained models and picked the best one and then optimized that. So there's a lot more that it really does. The user experience was super good. Okay, stability. Okay, I've been doing a lot of AI stuff recently. That stuff is so freaking unstable with all the libraries and stuff. I try and reinstall something, I got to reinstall it again, there's a conflict. This was so refreshing for me. It just felt solid. It was like totally dependable. So maybe it's just my recent background, but I really appreciate that. Okay, the documentation rocks. It's like a story. This is the first ever documentation where I actually sat like a little martini hour in the evening, and I'm actually reading. I know, seriously, I know it's kind of strange, but I'm reading the Heatwave documentation with my martini in my other hand. It was that good. And get this, they actually link outside of the MySQL ecosystem, their doc, outside of Oracle to non-Oracle documentation if you want to get to some of the really specifics of machine learning. Who does that? They take a risk that you're going to like leave their website. Nobody does that. And it was really good. It told me that they're honest and they're not trying to hide stuff. So I really appreciated that. And it's actually helping me to use the product. It's not like a feature list, which this is not helpful when you try and do this stuff. Okay, the integration was just so straightforward with Python, so I could use APIs, whatever I wanted to do. There's a massive Python community that's great, and it's just actually very straightforward. Okay, the integration, it wasn't complicated at all. So I think that's about it. It just works. Hey, I got to do a shout out for these. These are like my MySQL people right here. They're not here. They are fantastic. They were so helpful in all of this. So, what? Oh, yeah, they're going to love that. Presidi's actually seen this. Yeah.
One question, based on your experience, how much machine learning background one needs to use this system?
You don't need much. I mean, you need to know there's a model that's created and you get data and you put it in here. The hardest part for me was some of the pre-processing. Okay, and that's some of the questions I have. What is, in terms of like feature engineering and stuff like that, and which I don't want to get into that, but I felt like I needed to do some of that to get a better model. But you don't need that much. I mean, I've been challenged to create like a MySQL class that has 0 Python. And I think I could actually do that. I think I could do that, yeah.
So you said you didn't have very much data in there.
No, this didn't. I couldn't get it. Weather Underground was limiting me. Yeah. I don't know. It depends. I can't honestly answer that because it depends how they do the auto ML. Just because you have, like 100 million rows doesn't mean you give all 100 million rows to the algorithm, right? It can sample it. And there's a lot of tricks you can do when you're actually building, models like that. And I don't know how that's actually done. My guess is they probably do some of that sampling. Yeah, otherwise it might take a while. So. See, got it. Ding, got it. Yeah, you had to do that. All right, so if you guys want to play with this, I'll put the code out there next week. I want to clean it up. It's kind of embarrassing still, I even cleaned it up for the screenshots. I didn't have to install Apache to get it running because in Python, it's like built in, kind of a little web server. It's super cool. So thank you guys for listening at the very end of the whole day. Yeah, appreciate it. And if you want to check out Shane, there's the QR code or go to the booth and all that. So yeah, hey, thank you guys for having me. It's been an honor to be here. So.